Hello everyone, and thanks for taking some time to learn more about the Zenmuse XT2. My name is Randall Warnes and I run FLIR's SUAS business. In this short video we're going to cover the compatibility and configurations of the Zenmuse XT2, as well as some of the key features of the camera. On March 26th of this year, DJI and FLIR launched the next generation of their game-changing aerial thermal imaging collaboration with the Zenmuse XT2. The original Zenmuse XT was launched in December of 2015 and really pushed DJI into the commercial drone space. Through lessons learned and end-user feedback collected over the past few years, the Zenmuse XT2 is smarter and more powerful than ever. The Zenmuse XT2 is only compatible with select DJI airframes, namely the Matrice 200, Matrice 210, Matrice 210 RTK, and the Matrice 600 Pro. Each of these has about 25 to 35 minutes of flight time with this payload on board, depending on the batteries. This also means that the Zenmuse XT2 is not compatible with the Matrice 100, Inspire 1, Inspire 2, any of the consumer models like the Phantom or the Mavic, the Osmo, or any brand of airframe that is not designed by DJI. There are 12 different combinations of specifications available for the Zenmuse XT2. This is a more simplified offering than the original Zenmuse XT. There are two frame rates available, 9Hz and 30Hz, and this is because many of FLIR's thermal imaging solutions are regulated by US export controls. 30Hz versions are available in the United States, Canada, and the remainder of the STA countries. You may want to Google a list of the STA countries and see if your country applies. Otherwise, 9Hz cameras are available for most of the rest of the world in where the United States does not have embargoes. The Zenmuse XT2 comes in two different resolutions, 336 by 256, as well as the 640 by 512 option. Resolution is the largest price differentiator and can make all the difference in mission-critical situations. There are three lenses available for each resolution option. For 336 cameras, there's a 9mm, 13mm, and 19mm option. And for the 640 cameras, there's a 13mm, 19mm, and the new 25mm option for when you need to get more pixels on target but can't get too close. This is especially useful for utility inspections. Lastly, all the Zenmuse XT2 cameras are equipped with advanced radiometry. This means they have the ability to give you the temperature of each pixel within the scene, and this can be used for most post-processing images for greater temperature accuracy. The Zenmuse XT2 is also IP44 rated, so it is weather resistant. Frame rate is how the images are shown in the video stream each second. So 30Hz cameras show 30 frames per second, whereas 9Hz cameras show 9 frames per second. This means that you can have slightly choppier video or image with the 9Hz version of the camera. This video created by OEM cameras illustrates that difference. Again, the reason for both options are available is that 30Hz cameras are more closely regulated for export controls outside of the United States and Canada. Now, resolution refers to the number of pixels within the image. For a 640 by 512 camera, there are 640 pixels that go horizontally and 512 pixels vertically. This means there are more than 327,000 pixels in a single image. To identify an option or to get good radiometric accuracy, it is suggested to get at least 10 by 10 pixels on your target. That is one reason resolution is so important. With lower resolution cameras, you might be able to detect a subject, but as you add resolution, you could go to recognition of the subject to get more specific identification of your target. These cameras do not represent XT2 imagery that I'm showing here, but just to illustrate the point. Here are side-by-side images of a 336 and 640 original Zenmuse XT. At this distance, the images are not too dissimilar, but as you fly higher, you'll see more clarity in the 640 versus the 336. If you look in the distance at the pixels between the person's legs, you could start seeing this distortion where the pixels are starting to be averaged out and they cause some blur between the legs. Now, lenses offer different field of views, and that will give you either greater specificity and detail at the expense of seeing more within the scene, or you'll be able to see a larger range around the target but have less of that detail. The larger number on the lens, the more narrow of the scope you're going to see through the lens. So a 9mm represents the widest field of view, so you can see more area within the image, where a 19mm or 25mm is much tighter, but you get a lot more pixels on target. These charts illustrate the pixels and resolutions with different resolutions and lenses at 100 feet above the ground. With 19mm 640 camera, you're seeing about 57 feet from the left side to the right side of the image, whereas, you're seeing from the bottom of the image to the top 46 feet. This is similar to a 9mm 336 camera. However, you'd have nearly 4 times the amount of pixels on a 640 image, giving you much greater detail, and even allowing you to fly higher while still getting enough pixels on your target to detect it. Most users find themselves using either 13 or 19mm lenses on these cameras. Like I mentioned before, all of the Zenmuse XT2 cameras are radiometric, meaning they give you temperature data for each pixel within the scene. There are waves of energy everywhere in the world around us, and what our eyes see is this very small band that we call visible light. What thermal imaging cameras do is take in radiated energy in the infrared band and translate that into something that our eyes can understand. The Zenmuse XT2 is a long-wave infrared camera, and what these cameras do is translate that irradiated energy into a temperature reading. This calculation is radiometry, and putting in the correct inputs as a pilot is more than half the battle to get accurate readings. Along with ambient temperature, background temperature, humidity, and other variables, emissivity is by far the most important input to getting good radiometric accuracy. Everything around you is either absorbing, emitting, or reflecting radiation. The material each object is made of has a different percentage in which the energy is emitted. Things like concrete and brick are quite emissive, whereas things like aluminum or other shiny materials are more reflective. Inputting the correct emissivity of the material that you're measuring will provide you the best results and accuracy for your radiometric cameras. When capturing imagery with your Zenmuse XT2, you'll have 3 choices of file formats that you can use. That's JPEG, radiometric JPEG, and TIFF. The JPEG is an 8-bit image that gives you 256 different shades. These are images that would be used for display only, as they don't retain any radiometric data. For radiometric data, you'd want to use the 14-bit imagery that has over 16,000 shades that could represent a wide range of temperature variations. These will be image types that will be used for post-processing with software like FLIR tools. In FLIR tools, you can go back and change temperature or other radiometric variables like emissivity in post. And you could also see the temperature of every pixel within the image. That is something you can't do with TIFF files, is you can't change those radiometric parameters after the fact. The Zenmuse XT2 also has the ability to record radiometric videos, so you'll have 30 frames per second of imagery that retains that temperature data. However, radiometric video may not be suitable for things like orthomosaics. Now let's talk about some of the features of the Zenmuse XT2. Fundamentally, the camera offers both high-resolution thermal and RGB sensors within the same camera, but with the brilliant engineering of DJI and FLIR, features have been added to give the camera greater ease of use and ability to do the job correctly. Let's take a look at each of these features one by one. Temp Alarm allows you to set a threshold temperature, and as the camera is flown around, anytime that something goes above that temperature threshold, an alarm will sound. This can be useful for a variety of inspections, as well as some search and rescue cases. When the heat track option is activated, the camera will stay focused on the hottest object within the scene, and that will allow the pilot to move the drone around and get different angles and perspectives of the target subject, while keeping the subject centered and without having to manipulate the camera manually. Temp Check allows you to tap on the screen of the Pilot app and get real-time radiometric reading of any pixel within the image. This will allow real-time estimations during your inspections. So you can basically tap on the screen and see the temperature of each pixel real-time. Quick Track is like Follow Me modes that you may have used with Phantoms or Mavic airframes, but in thermal. So when Quick Track is on, you can tap on the subject that you're interested in, and the drone will keep that target locked on within the scene of the image. Isotherms are back with the Zenmuse XT2, and it's a valuable way to highlight subjects of interest. With isotherms, you could set a parameter of temperatures you want to be highlighted, and the camera does the rest. Here are some best practices for setting these temperatures for firefighting and finding people. Keep in mind, isotherms are not always going to make the imagery better, as it could be that your subject is nearly the same temperature as the surrounding area. But under the right circumstances, this is really a game changer for public safety users. MSX is multispectral blending technology proprietary to FLIR. With both RGB and thermal sensors in a single unit, MSX takes the edges of the RGB image and embosses them over the thermal image, giving you more context and detail in a single picture. As you can see here with this propane tank, the thermal image allows you to see the volume level within the tank, but the placards and labels don't give off a different thermal signature. By adding this detail, only seen in the visible spectrum, now you have one image that tells more of the story. Lastly, picture-in-picture mode allows you to view both streams of video simultaneously. This can be toggled back and forth, as well as show the map to make each flight more meaningful and make sure you don't miss a single second of critical data with either of the sensors. These cameras are for sale today and can be purchased as a kit, that means with the airframe and with a license for FLIR Tools Plus from FLIR distributors, or as a standalone camera if you already have an airframe or want to source it separately. For pricing, contact your favorite reseller of drone technology, or you can contact me directly and I'll make sure I take care of you. We'll start shipping the first batch of these cameras in late April and into early May.